Is going to focus on determining how to do percent composition calculations, as well as reviewing the metal activity series to make sure we have the key skills needed to successfully complete the Floating a Penny lab in material science. So let's start by reviewing percent composition. How do we calculate percent composition? Percent composition is the relative amount by mass of one component compared to the mass of the entire component. So the formula for percent composition is part divided by whole times 100. What's the mass of the part divided by the mass of the whole times 100? So if we were going to find the percent composition of this pumpkin pie with whipped cream, then we would need to find the mass of the whole thing, the pumpkin pie and the whipped cream, and then perhaps the mass of just the pumpkin pie. In doing so, we would take the mass of the part, just the pumpkin pie, divided by the mass of the whole, the pumpkin pie with whipped cream, and multiply it by 100 to get the percent composition of pumpkin pie in this plate of pumpkin pie with whipped cream. So let's do a quick practice problem. What's the percent composition of zinc if a 25-gram sample contains 10 grams of zinc? Well, let's use our equation, part divided by whole times 100. So the portion that is zinc is 10 grams. The mass of the entire thing is 25 grams. If we multiply that by 100, 10 divided by 25 times 100, we should see that it is 40% zinc. What would the percent composition of the other substance be? Well, if we think about it, our percent composition should always be equal to 100%. So if there's only two components and the first component is 40% of the sample, the second component should be 60% of the sample, as they should always add up to 100%. Let's take a quick second to make sure we can calculate percent error correctly. Percent error is to find the difference between your experimental and theoretical value, then divide by your theoretical value before multiplying by 100. Order of operations matters in these problems. Be sure you use parentheses and subtract the experimental minus the theoretical before doing your division and multiplication. So let's do a quick practice problem. Calculate the percent error if a student determined the percent composition of tin to be 76% experimentally, but the theoretical percent composition was 81%. Our experimental value should be 76. So we're going to take 76 minus 81 divided by 81 times 100. 76 minus 81 is -5. -5 divided by 81 times 100 is -6%. All right, we need to briefly review the activity series as this lab uses the activity series. And we've already covered that in our second learning target of the year. But let's go back and look at it again so that we have the ability to be successful on today's lab. How can we use the activity series of metals to determine which reaction occurred? So if we look, we have an activity series right here, and we have 3 reactions. Let's take a second and decide whether or not a reaction would occur. If zinc is added to hydrochloric acid, zinc is right here. Hydrochloric acid contains hydrogen. That's the part that acts like a metal. So the zinc and hydrogen would be trading places. So zinc is here. Hydrogen is below it on the activity series right here. That means a reaction will occur because zinc, the solitary metal, is above hydrogen on the activity series. So we'll get a reaction, and the reaction, they'll trade places. So zinc will now be bonded with chlorine, forming zinc chloride, and hydrogen will be all by itself, creating hydrogen gas, H2. All right, let's try this problem. Ag is silver. If silver is right here and the hydrogen in hydrochloric acid is above it, reaction or no reaction? Hopefully you said no reaction because silver is below hydrogen on the activity series, so it doesn't have the ability to replace hydrogen in the compound. All right, let's try the last problem. SN or tin. Tin is right here. It is above hydrogen in the hydrochloric acid. So hopefully you're deducing that that will be a reaction. And the tin will combine with the chlorine to form tin chloride. Hydrogen will be all by itself, H2 gas. The big rule that you've been deducing on the activity series is that if metal X is higher on the activity series than metal Y, the reaction occurs and metal X displaces metal Y from the compound. All right, let's do an example problem. I would strongly encourage you to write this example problem entirely into your notes, as it's a great way to see and practice the calculations before doing the floating a penny lab. An airline part is made of aluminum and plated in silver. A student reacts it with hydrochloric acid. Which metals, if any, will react? So to solve this problem, we need to use our activity series, and we can see we should be comparing aluminum with hydrochloric acid and silver with hydrochloric acid. Essentially, if we react aluminum with hydrochloric acid and silver with hydrochloric acid, our job is to determine which of these reactions occur, if any, so that we can move on in the problem. So aluminum is here, which is well above hydrogen on the activity series. So using the rule discussed earlier, we should definitely get a reaction. Aluminum will bond with chlorine to form aluminum chloride, and it will also produce hydrogen gas, which will be displaced. If we look at silver, silver is below hydrogen on the activity series, so it doesn't have the ability to displace hydrogen from its bond. So there will be no reaction. All right, take a second and think about what this is telling you. If we put this airplane part into hydrochloric acid, the aluminum will be reacted, the silver will not be. So after the reaction, we'll have a solution of aluminum chloride and no more solid aluminum. It will be completely reacted, but the solid silver will be left behind unreacted. That allows us to fill out this data table. Before the reaction is the mass of the entire piece of aluminum, 32.58 grams. After the reaction would be the mass of the unreacted silver, what's left behind, 7.82 grams. That means that the after reaction mass represents the mass of silver because it's what was unreacted and left behind. And can anyone figure out how did we get this 24.76 number? It's not a number that we measured directly. Hopefully you told me that that was due to the law of conservation of matter. If this is the mass of both the aluminum and silver portions before the reaction, we can subtract the mass of the unreacted silver from it. 32.58 minus 7.82 gives us the 24.76 grams. And that is the mass of the aluminum that was reacted. The difference tells us how much aluminum was reacted. So to find percent composition, we're going to be using our two values over here. This is the part of the product that is silver. This is the part of the product that's aluminum. And here's our total mass, the whole. If we want to find the percent composition silver, we'll take our part, 7.82 grams, divide it by the whole, 32.58 grams, and multiply by 100. And we should get 24% silver. If we want to do the same math for aluminum, we would take our part, 24.76, divided by our whole, 32.58, divide those values and multiply by 100, and we should get 76% aluminum. So if we look at your floating a penny lab, in your floating a penny lab, we can see with a penny that's been cut through that we have two metals. Copper, which is plated on the outside, just a thin layer of copper, as well as zinc, which is the metal that makes up most of the mass of a penny in the middle. So we need to compare the copper and the zinc to see which one's going to react. And hopefully we can see that if we add this to hydrochloric acid, zinc is above hydrochloric acid on the activity series, so the zinc portion should be reacting, whereas copper is below it, so it's going to remain unreacted in the acidic solution. That's why the lab is going to ask you to use a metal file and file away some portions of the penny, because without filing it, the acid won't be able to get to the middle of the penny and the zinc to react it. We need to remove some of the plated copper from the outside, since the copper does not react with the hydrochloric acid. So the reaction that you should see in this lab is zinc plus hydrochloric acid is going to produce zinc chloride in solution and hydrogen gas. The copper will be unreacted at the end of this lab. If we look at our data table then, the total mass before the reaction would be the mass of your penny after you file it, before you add it to the hydrochloric acid. And after the reaction, there's some strong visual clues that the zinc is the metal that reacted and the copper is the metal that is remaining. So the after reaction mass is going to represent the mass of the copper, and we can use the law of conservation of matter to look at the total mass subtracting the mass of copper to determine the mass of zinc that was dissolved. I hope this podcast was helpful. Have a great day.